Okay, so number 1, your absolute max happens at C. Your absolute min happens at D. Relatives are A and C for max and B and D for mins.
I put numbers. I thought you told us to.
Oh, I mean, you have to for increase and decrease. You didn't necessarily have to for...
I mean, I highlighted and put absolute max and absolute min, but for relative, I put -4 and 2 and -2 and 3.
That's okay.
Okay.
That's fine.
I thought you couldn't have an absolute on a point.
Yes, you can. You can't have it on, like, an end point.
I know that. But I thought you couldn't have.
But it's going from down to up.
But I thought you couldn't have an absolute on a point, on a cusp.
You can. Right, we've talked about this. Maxes and mins happen when the derivative is 0 or does not exist. Okay, the derivative would not exist at C, but it can still be an absolute max. Kate, are you looking for colors?
For some reason I was thinking if it's a point.
For what?
Oh my god.
Kate, I have pencils. I'm about to just let you...
Where you took the 6 out?
All right, but you give them back. It's fine. All right,
I
guys.
feel bad to take them.
Okay.
That's what
All right, so you're increasing from negative infinity to -4 and -2 to 2 and 4 to infinity.
Good job, Katie.
You are decreasing from -4 to -2, +4 to infinity. It's the last one.
Oh, okay. I was looking at number 3.
And then 2 to 4.
And I was really scared.
I just read the Y.
Yeah, so remember, use X values for increase, decrease. Okay? I feel like these two are... Dylan, is that my pen? Where'd you find it?
I laid it over there with my stuff. I borrowed it last period and I just had it over there with my
Oh,
stuff.
but I was looking for it the other day and couldn't find it.
Well,
that's
I just
weird.
borrowed it today.
Oh,
I didn't see it.
okay. That's fine.
Found it.
He did find it. It's like I sent a text in the group chat in the staff group chat looking for my rainbow charger that I thought had been missing.
Yeah.
It wasn't missing, guys. It was literally tucked behind this and I didn't see it. It's fine. But now Mr. Patton has it. He was borrowing it. But now I know who to hunt down when I can't find it.
I feel good about this one.
Okay. We go with 1 and 2?
Yep.
Okay.
I made a dumb mistake, that's it. Dumb point.
All right. So, your first derivative should give you... Where's my apple pencil? There it is. I need the VeggTales version of where's my apple pencil. So, again, you get 6x squared plus 6x minus 12, okay? Then setting that equal to 0, right? I didn't actually write equal 0. I probably should have.
Did you mess up your increasing?
Oh, crap, probably.
No? Yes, you did.
Yes, you did.
Oh, increase. Yes, you did.
Oh, I did.
You
Made a mistake.
We're going to talk about my one mistake versus your all thousands. Okay, all right.
That's fake.
Again, I did this test like 6 times yesterday. It's
Why?
fine. Because I did it one time and then I changed a bunch of questions because I didn't like them. And then I did it again and then lost that one. So then I had to do it again to like time myself to make sure you guys would have enough time to finish it.
Time yourself.
I timed myself and then like multiply it. Like, so it took me like 12 minutes.
It took you 12 minutes.
She freaking...
It took us 2 class periods.
She speed runs back, okay?
It took me 2 class periods. Not kidding, not exaggerating. To do number 6.
To be fair, I think I forgot to start it at one point, so I'll probably add a couple minutes, but
Still, it took us 2 class
Oh,
periods.
so what, like 20 minutes?
sure.
So her 20 minutes converts to... Hold on. What's 45 plus 45? That's super
90.
question. What? What did you say?
45 plus 45 is 90. I answered your question.
So, like, her
See, he
20
had to get a
minutes...
calculator out, add some time.
He's like 4.
Yeah. Her 20 minutes convert to 90 minutes for us. That's crazy.
That's not terrible.
Your
I'm
math teacher said.
I'm supposed to be able to do it fast, right? That's why I don't expect you guys to do it in the same amount of time as me. I find my time and like use that like I multiply it usually. Okay. It should take you guys at least 3 times as long as me.
It will take far more than that.
Yeah, that's.
So like if it takes me 5 minutes, I would expect it to take you guys like 15. Like
That's like...
Like 45.
Okay, so anyway, I did mess up my increase decrease. But you take out the 6 and then factor. Did we factor right?
Yeah.
Oh, hallelujah. There's
I taught
hope.
them.
Okay, so then increase, decrease, max, min. We got that?
Yes.
We're looking.
No, wait, Maxman, my Maxman's wrong.
Use your what?
Right, because you're increasing.
Oh, no, it's a negative 2 because we know it's
Decreasing.
happening on either side of it.
Yes.
Okay.
Wait, so what is it
I'm
again?
pretty sure it's looking kind of fire.
Your min is, oh my gosh.
You're
I
slurring.
got a max and min right.
Good job, Isaac. It's clicking.
Amazing.
Wait, did I? Yeah.
All right, that's the whole point of this. Is you guys are supposed to be checking.
I got
I
right.
checked everything else. It's not bad.
Oh boy.
I got the first one. Oh, here we go. We're gonna go over here.
All right, ready? Number 4.
What about this
Technically,
one?
we never talked about this.
You're right.
We not equal to E.
Wait, I need a pencil. Hold on. Kaylee, give me a writing utensil. Quick. Burr, burr.
Oh, well, crap. I
Caitlin.
just messed it up.
Nope, I
think
hit the
found a
chair.
pencil. Hold on, don't throw that yet.
I wasn't even close.
No.
See, I got my numbers wrong. That could be it.
Hey, what does E equal? Like, is it just,
2.7.
Roughly, yeah.
how do we know that?
Because you put E and then equals and then it gives you 2.7.
Yeah, I think-
I did not know it did that. That's cool. I
It's
forgot
like you
we
put
did that.
pi and it gives you 3.14.
I figured that out yesterday and I thought I was super smart.
She thought she had it up.
Okay, all right, so you have to do the quotient rule to take the derivative, right? So we do the bottom, right? Times the derivative of the top. So derivative of ln x is 1 over x plus the derivative of x, which is 1. Minus the top, as it is, times the derivative of the bottom, which is just 1. Okay, I just wrote it there to make sure you guys know I did all my steps. Okay, over the bottom squared, so x squared. Right, so then I distribute the x. Right, so x times 1 over x is 1. X times 1 is x. Okay, and then I distribute the negative through to this, so that's why it's minus ln x and minus x.
Yes.
Okay, so then on top now, you're left with 1 minus ln x over x squared. That's your first derivative. Okay, so now we're going to set the top and bottom to 0. Bottom, right, x squared is 0, so x is 0. Okay, top, back to solving logarithmic equations like we do in Algebra 2.
Is it negative ln x equals 0? Yeah.
Or, yeah, 1 minus ln x equals 0. 1 minus.
1 minus, sorry.
Okay, so then subtract the 1, divide out the negative, okay? So then to solve that, you have to get rid of the ln x. So if you have this, right, you're basically taking e to the power of ln x equals e to the first power, right? Because the e and the logarithm, like the exponent and logarithm, cancel each other out.
Can you put that in the calculator? E to the ln x?
I mean, you could, yeah, but you have to know to do that is the problem. Okay?
Are there other rules like that one that we need to know?
But the problem is it's not going to give you, I don't know that you can put the x in because it's going to pick up x is 0, so it won't work. So x equals e.
Are there any other rules like that one that we're gonna need to know for test?
No.
X equals.
That is
I would have never guessed that.
Okay? We got to know how to work with logarithms.
because I messed up so stupidly.
So,
So then now your critical numbers. So then you guys probably got here, right? And you tried to plug in a negative number
That didn't work.
and you got a domain error,
I put 1 and 3.
Facts.
right? Because you have 0 in e. Because 0 is a critical number as well
Hey.
from this.
Your 1 is
I
the
didn't put a
negative,
0 in.
I think.
I didn't do negative numbers.
1 minus ln 1 is no. Because
I
ln
think-
of 1 is 0.
ln 1 minus 1.
No, 1 minus ln 1. That's why.
1 minus ln.
Because it's 1 minus ln x. This is your derivative you're plugging into.
Idiot me, I wrote it backwards. It's not bad.
Yeah, it makes a difference. That's why your signs are going to be backwards. Okay?
That's crazy.
So again, remember, you cannot take the log of negative number or zero. Okay, so that's why this doesn't matter. Doesn't happen. Can't do anything there.
Is that, did you cross out the zero as well?
And I know that I know that I wrote the zero there just because I know that that's like, it's technically a critical number, but like nothing's happening on the left side of it.
I thought,
Does your ln always come
positive.
Right, so you should get, right, so 1 minus ln of 1.
You see, I don't get where the 1 over x is getting.
Oh,
What happens to it?
Here,
Yeah.
so I multiply x times, because x times 1 over x is just 1.
That's where
Okay.
I get it.
All right, yes, Kate.
I know this is such a dumb question because we've already done this 1,000 times. When my brain gets to a part on a test or something and I need it, like
Okay,
the critical or the numbers that we pick out or to find positive and negative, we plug those into the derivative, not the original problem.
correct.
Okay, because I messed that up one time. No, remember what
I got to positive for 3 when I plugged in 3.
You did 1 minus ln 3 over 3 squared.
Yeah, when I really choose.
Is your thing? Does it have to be in a certain thing? Does it have to be
Mm-mm.
red or red? Because we're working with.
Because on this thing I got positive.
Kaylee, what is happening?
What?
No, 1 minus ln 3 is negative 0.0986. Divided by a positive 9 is still going to be negative.
Oops. 3 squared. Positive 0.877.
Did you wait?
When you take the ln, is it always going to be e, even if it's a negative or positive ln?
Depends on what it's equal to. It'll be e or e to the something. Like if it was ln x equals 2, it would be e squared.
Or do what's e squared equal?
That's your problem.
What?
It's doing all of that first and then squaring. Why is it doing that?
Let's find out.
That is a calculator error. Because I put it in both ways.
7.3.
Because like, like if you do that and then divide by 9.
What? I have never done anything like that. I've always done it divided and just put the numbers.
Why does
What
e
did you do
stay
differently?
positive?
I didn't put parentheses
Where
around
did e
3.
come from?
I didn't at first
And I
either.
did it. I did here though.
Why would I
Why
ever
does
do
e
that?
stay positive?
That's why. Because look,
Does it really ln
That's it.
equals e?
See, why do these can't
Alright.
be every time?
order of operations, right? It's gonna do this
What happened?
ln 3
Like
divided by
by
that
9
and then do
divided-
1 minus it,
one?
right? So instead of trying to put it all in at once, to avoid that, I always just do
Break
do
it
the
up with
top.
LNs.
I do the top. Like I put, like if you have a fraction, I'll put the top part in, hit enter, and then divide, and then do the bottom part. Okay?
Near the bottom. Because
was
negative
it-
ln x equals negative.
So I was literally right. It was
Yeah.
Because we divided by a negative.
like I'm all right.
Because there's a negative 1 in front of the negative ln x. It's technically negative 1 ln x.
Okay, that
And then you divide it to make it positive.
makes sense.
Okay.
All right. We okay with 4 now?
Yeah.
So
Hint, hint, nudge, nudge. Study that one. Real good.
positive 1, negative 3. Wait, I need to put my increasing and decreasing.
0 to e for increase, and then e to infinity.
Oh.
Where'd you get the x equals 0 again?
From the x squared equals 0. So then the bottom equal to 0.
I got all the right answers.
I was there, I just wasn't there.
I was there.
The last part was hard. I knew it was going to be.
Hey, I think I did good on number 5.
Hey, why is yours set different? Like, mine's set up, mine's set up ln x plus x minus 1 minus 1x.
What?
Like,
You did it backwards? You quotient ruled backwards?
See, I think I told you you can't quotient rule backwards.
you're right.
It messes all your signs up.
So it's the first times the root of the second.
Quotient rule. Bottom times derivative of
Oh,
top.
what am I doing?
You're doing the product rule.
Um,
Bottom times the derivative of the top minus the top times the derivative of the bottom. You always got to start with the bottom.
Okay.
Over the bottom squared.
Okay.
See, this one, I don't know where I went wrong. I think because
No.
Wait, number 5.
So top times derivative of the bottom?
Okay, I got a positive on the
Bottom
negative
times
negative
derivative
on
of the
the
top.
Sorry.
yeah, I'm the same way. I got
Okay.
it backwards.
I got a positive and then a negative.
Yeah, me too.
Me too.
Did I mess up?
I hope.
Maybe.
But I also used
I hope
negative
so
1
because
and
I'm-
1.
I got a positive 1/3.
Yeah, we all did.
We
What-
should.
What?
But then I got a positive.
I got
Right, so 0 is definitely less. What numbers did you use?
negative 1 and 1.
I use 0.
0 is always
I
a
use
positive,
0
ain't it?
and 1.
Right,
I use
so-
0 and 1.
And I got
Isn't
positive
0
negative.
always?
I did it in my head, but I
No, you are
It would
100%
be
right.
positive
I'm
because
wrong.
A negative times a
Yeah.
negative is positive.
Right, so if you plug in 0, you get 0 plus 2. You're right.
Right?
Whoa. Why is
Oh,
your
yeah, I thought
POI
it was
x equals 1/3?
No, we didn't get to talk
I
about
thought
Because
it.
it
that
could be
one.
POI.
I'm videoing the whole thing.
But I feel really good about it right now.
Do you want to look at it real quick?
Yeah.
Can I show her 6 real quick, guys?
Let's look
So then it should be a plus, then minus.
Look at the sin cosine one.
Oh,
Pause. Maybe I'm not feeling good about it.
I wrote really big.
The only
I
thing
did it.
I missed is I said that the 3 could be a thing. But it
yeah.
can't.
No, I didn't.
I said 3 could be a positive negative.
I got it
Yeah.
actually.
I got it.
Do we understand why I said eh?
Then I kind of slayed on this thing.
Well,
You're gonna be fine.
Because technically negative and pot. The negative
It was just
third
the
is 3.
Ellen, and I put it all right. It was
And because you can't test anything outside the negative 1 and 1.
Which actually I did
I'm
pretty good on number 6. I did good on number 6. After you.
Because if you plug in 1 or negative 1 here or anywhere, you're going to get 0 on the bottom.
Yeah, go get my clothes off my car.
Or,
So why then would the square root of 3 not work?
Bye, guys.
see ya.
Because it's the square root of negative 3. Because you end up with x squared plus 3 on the bottom.
I completely dropped my sign like
Where am I getting that? No, wait.
I'm confused what a POI is.
Point of
I
inflection.
got x squared minus 3 on the top.
It's like a max and min.
I
It's
was
like a
looking at,
critical
the
number.
test, or like the practice, and some of them had a plus or minus, and it in the middle, and it wasn't a POI. But the ones
It
that
should have been.
but the ones that did have a POI had a plus plus and a minus, or a plus minus minus.
Then there would be 1 where it changes from plus to minus. It's like where a max and min happens.
So if there's a plus, so if there's any change in direction at
Yes.
all,
It's a
POI.
yes.
Okay.
Did I mess up? Wait.
No, it's definitely a negative, a positive negative 3.
Your 2x x plus 3 is that wrong?
No, it's definitely
No.
negative 3,
It
because
should
I
be
didn't do
negative. I
my
took out negative 2x. Why did you get a positive 2x?
Because you have negative 2x cubed plus 4x cubed is positive 2.
Upside down. Mine are switched back. My 4x is negative and my 2x is positive.
Did I mess up?
I don't think so because I should have it when I
No.
look back at it.
You're right.
I did this one a lot.
No.
Wait,
Now, no,
You could take off a negative.
why did I do that? That's
I'm not understanding something.
You could take out a negative 2, couldn't you, and make them both
Why
positive?
did f prime make that so much bigger?
because then I did the quotient rule. Like
Why?
quotient rule,
You double quotient rule?
you have to because you're doing 2 derivatives.
That's where I went wrong. So,
Okay.
Gosh, that's a mess.
This doesn't seem right. Why did I do that? Because those are numbers and you check on either side of them. That was dumb.
I don't get what happened. I did. I got all of this, but my Okay, I know what happened.
No, I don't. 'Cause you canceled.
No, you're wrong somewhere, aren't you?
I think she's right. I felt like I could take, what I did was I took out a negative 2x, which was.
All right, let's walk through it.
for me to
I
get-
know what happened. I didn't know that you could take.
Did we end up with the same first derivative?
Yes.
Yeah, well, I just didn't know that you could take the chain rule, that x squared minus 1 out before you, like, finish solving your chain rule part.
Oh, before you started like combining?
Yeah.
Yeah, so that's what,
So
'Cause
then
once you
I
start
waited till
throwing
then and I
stuff in-
messed it up.
okay, because once you start like,
Yeah, but you're.
it's hard to cancel once you start distributing.
I
Shouldn't
get
there
what
be a
happens.
4x
I
in
just
here
want to
somewhere?
know the explanation for
When you do the
not-
quotient rule the second
you
time,
saying
shouldn't there
that's
be a
not
4x?
though, maybe,
Yes.
Because that is
Where'd it go? Oh, it's at the end. Why is it at the end?
Because I did, all right, so bottom times the derivative of the top minus the top times the derivative of the bottom, which is all of this. And then 2 times 2x becomes 4x.
The derivative of the top for that one, wouldn't it be 2x minus 4x? 'Cause the
No.
One, the one goes away and then the 2x squared turns into a 4x.
There's not a, oh, here?
Oh, I did that.
Yeah.
Look, Dylan, I did x squared minus 2x squared and have a negative x squared here. And then did the quotient rule. I combined those together first.
I know what I did. I'm good.
It's so bad.
I think I know what I did.
But I just want to know why you're saying not in domain, because I know it doesn't exist at that point.
Yeah,
Where's your POI at?
we're gonna do that together.
Okay.
I was very much out of it, I think, by the time I got to this part yesterday. Because, like, you absolutely can check on either side of it. That was one of my
POI is
dumber
up,
choices in life.
But still.
So, 0 and 1. Like, you can check all those. You're fine. It's okay. So then you can check -2, -1/2. Can you see the green okay? 1/2 and 2. We can check stuff there, but I know that's positive, and that one was negative. So -2. No, I think it's positive.
When I plugged in 1/2, I got positive.
-2. Oh, it is positive. Yeah, because it's a negative and it's a negative. Yeah. No. I thought this.
Hold on. Because then you have
Is negative.
-2 squared, so 4 minus 1. It is negative. Wait a minute.
I only got 1 negative.
Did IXL lie? Not IXL. Photomath lie to me.
I think because that's negative, because the cubed makes it negative and the x makes it negative, and those add as a negative, and then the bottom is positive when you square it. So the top's negative and the bottom is positive. I never actually do.
Why did I do this? I had to check this one so many times yesterday.
Yeah, this one's a toughie.
Cute, what did you get for your positive negatives? I got negative, positive, positive, positive. And I feel like that's probably incorrect.
Because I know I checked Photomath yesterday and had to find the points of inflection, and it only said 1/2 and -1/2. Stupid Wi-Fi. Okay. Try it.
Yeah, mine's wrong, so I can't.
Yeah.
Negative 2 cubed is negative, so then 2 times
Find
whatever that
inflection
negative is,
points.
plus a negative,
Show solving steps.
it's a negative.
Nobody cares about it being symmetric.
It's negative, I'm sure.
What? So my second derivative is correct.
If I messed up and I got positive for negative 2, but that's because my thing was wrong.
So it's saying there's no inflection point at -1 or 1.
Well, it doesn't exist.
Okay, hold on.
We know it doesn't exist at 1.
I know, but it's saying that it doesn't change concavity there. So it's saying that they should be the same sign on both sides. So,
Can it not change concavity if it doesn't exist?
it can.
I still don't understand why it doesn't exist at -1 and 1.
All right, so -2 cubed is -8.
Yeah, it's gonna be negative.
It's negative.
Yeah.
Why is that not an inflection point then, photomath?
Because maybe it can't technically change at exactly -1.
Okay, so this is saying since the function is not defined for x equals -1, the function has no inflection point.
She's gone.
You can get back to it, Marta.
Do you want to see my brochure? Ooh, my brochure. I'm just writing the paper, and I haven't started yet. I'm really lazy. Ooh, this is fancy.
That's gross.
Miss
So
Letterman.
cute.
So this is saying that you can't have an inflection point there because but that's yes.
When you distributed your negative on your second derivative,
Uh-huh.
did you take the derivative of the inside as well?
Where? Here?
No, down.
Here?
Down.
Here?
Yes. Why does that turn into a 4x to the
I took the negative in and multiplied by 4x.
You have to do that?
Yeah.
Okay, so it's
So
multiplied
what is
both
my-
ways.
So it's
You
x.
see, I didn't see the arrows.
I'm looking at the graph of this because that's going to make this make more sense. X squared minus 1. Whoa! What syntax? You just graphed it. Oh, delete. Nobody cares about that graph. Whoa, is right.
I'm a wee bit worried for this.
I wouldn't be.
I'm horrified, but it's okay.
This no one guys are really stressed about anymore.
Oh, okay, I get it.
Explain.
So your graph. It's also a great way to check yourself with this.
Is that allowed?
I mean, I'll let you use this, so yeah. So if you hit y equals on top, okay, and then that's what lets you type in your original equation, okay? And then you hit the graph button and it pulls up the graph.
How do I know if the graph is right?
Trust the calculator. Trust that you put it in
No,
right.
she meant like, what if her numbers are wrong?
This is the very original
It will
function.
be changing on your.
You haven't done anything to it. It's the problem I gave
Can it
you.
not graph if it's wrong? No, you don't put in you don't put in your answer.
You do no work. You just type in what I gave you on the test.
You type in the problem, and it graphs it.
Why do we need that?
Like you would type in x over x squared minus 1, and it would graph it.
Right, and you should be able to look at that and be like, oh, look, max, min, changes concavity, because you know what those things are.
But will that change when we actually do the graph? Like
So
actually
there
like
are
solve
two
it?
different graphs on this one.
So it's like, it's in pieces, because it doesn't exist there, so it's not a point of inflection, because it's not changing, because it's on two different pieces. That's why.
How do we know there are two different pieces?
Because it doesn't, so like, you
Well,
know
if
that
I
since
take the
since it can't exist there, even in the original one, like, you know that at -1 and 1, you have to have asymptotes there. So, like, nothing is happening at that point. So stuff can happen here and here and here, but not through the, like, it can't connect.
Yeah. Why can
That's not
it could have an open circle there?
Huh?
It could have an open circle there.
It could, but typically with something this big, it won't.
So there's
Well,
no
I
points
always
of
thought there was an open
inflection?
circle there and broke the thing.
So So the point of inflection is 0.
I will make sure not to give you one that gives you that kind of issue. But, like, if you guys had done this and this, like you got, and then wrote them all as POIs, I would not have dug that deep to count against you. Okay?
So
So just do what you're doing.
if we would have wrote -1, 0, and 1, is that technically?
That would be, I would have counted that right.
As a POI?
Yeah.
Okay.
So,
That was confusing.
it was, you're right. I should have had you guys learn to look at graphs more
Why
often.
did you not find the ones on the twos?
That's where we were having a discrepancy with photo math, but just
On the
ignore.
twos?
The twos aren't, that's just, those were test numbers. Okay, let's look at the last one. Were we okay with 5? Did I need to go back to that?
No. The critical number was 1/3.
Okay. And then I had mine backwards, but we
Yeah,
fixed it.
you're, so that is right. What you had but backwards.
She
Yeah.
had Oh, is that it?
Crap. No? No, that's not what I got.
Yeah. Oh, heavens.
Oh yeah, no, I was. There was no way.
No, oh, no, I still missed it.
There was no way on God's green earth I was getting that correct. Not even
I
close.
thought you had to use pi and 2 pi.
Caitlin got it all by myself. I think you didn't help me though.
You confirmed what you had was correct. Yes.
But I already had
I did not help you
How
get
do
there.
you solve down the unit circle?
I
Okay.
set them separately.
So, on your unit circle, shall we insert? I think we should. Unit circle. Ta-da! Look, it came to join us. Okay, so you want to find when sine and cosine are equal but have opposite signs, right? Look up. Because they're the same, but so like negative sine and cosine. Okay, so the only places that sine and cosine are the same are at anything that's pi over 4. So pi over 4, they're the same, but look, the signs are the same, so that's not what we need. Okay?
See, I didn't understand because I got to where you're at, like the negative sign x.
You got here.
But
Okay.
I don't know. I didn't know how to plug that in.
Okay, so that's when you have,
They equal each other at pi over 4.
because that's when they're always square root of 2 over 2.
But like, I thought you had some negative signs.
Okay, I'm getting there. Right, so look, this one's square root of 2 over 2, that's square root of 2 over 2, right? But they don't have opposite signs. Not like S-I-N-E, like S-I-G-N signs. Okay, but then here, look, you have a negative square root of 2 over 2 and a positive square root of 2 over 2. So that happens at 3 pi over 4. And then doesn't work at 5 pi over 4, they're both negative, but at 7 pi over 4, they're one of each again.
So if you have nothing to go off of, and it's sine x and cosine x, you either look for them both being positive, or I mean, you would always have to look for one of them being negative.
So like say you had sine minus cosine equals 0, then you would end up with sine equals cosine. Then you would tell me the ones where they're the same.
Okay.
Or if it's just one of them, if you get like sine x equals the square root of 3 over 2.
You don't set them each separately equal to 0.
Okay.
You can't when they're subtracted like that. If they were multiplied, you could.
Okay.
But since they're added and subtracted, you
How
can't,
do you
right?
know which, like, whenever you need one of the, like, different signs of the same sign?
So this is one, this has a negative, this has a positive. So different
Is that
signs.
your second derivative?
Yes. My first one is cosine minus sine.
But your second one is negative sine minus cosine.
Yes.
Right there, it's negative sine, positive cosine.
Right, because I moved it over. I set it equal to 0 and added. Oh, did I not? I didn't finish checking the last one. Mode,
Does
radian.
it say 11 pi over 6?
Yeah, and I didn't check that one. So negative sine 11
If I
pi.
had just used like easy numbers, like point something, something,
I did 7.5 pi over 4.
Why'd you make it?
I'm
so
sorry.
Same.
You did what?
7.5 pi over 4.
to make it
Check and see if
bigger,
I'm right.
to make it bigger, to make it smaller.
Check and see if
What?
I'm right.
I'm sure you are.
Why did you do that to yourself?
Because she's not wrong, because it's a little bit bigger than 7 pi over 4.
If it was 8 pi over 4, then it would be 2 pi, and it can't be, so it's a little bit smaller. 7.5 pi over 4.
That's crazy. Is it right? Shake it. Is it right?
It is right.
It is. Yeah, you are right, because that's the same as 11 pi over 6, I think. Is it?
Yes.
Caitlin, that's honestly good math sense. I'm very proud of you.
Slay. I didn't know I had that.
Yeah, it's negative. I'm sorry, so hold on. 7.5 pi divided by 4. 11 pi divided by 6. Oh, they're a little different, but what you have is correct. It's in between there. You're not wrong.
Heck yeah.
What if I just put like whatever, like equaled it out to like a regular number with no pi in it? Is that fine?
So is your
What?
Like if I don't put pi in that number between like.
I don't care. I just,
a number between.
I personally find it easier, like, because at pi over 2, sine and cosine are either -1 or 0. Like, that's why I did that. But I don't care what you put there, as long as it's between the numbers.
I don't know how to find a node.
so what's your POI?
Is 0 positive?
3 pi over 4 and 7 pi over 4.
Negative.
0 is neutral, neither.
So what do you get 0 when you do that?
Then that means you didn't find, that means that should be a critical number.
I was gonna say I almost slayed, but you helped me with some of this.
But do we feel better?
Not about number 6, but better.
Do we
Number
feel,
6 is easier than number 7 in my opinion.
Number 7 I did super fast. It took me too long to do.
I will also send this video to all of you, that way you can listen to me talk through it again if you need to. The comforting voice of me teaching calculus. Just listen to it while you fall asleep and it'll soak in there.
I'm just trying to
I probably will do that just so I can actually.
Oh,